My name is Joe Grand, and sometimes people know me as Kingpin. And yeah, I like to say that I'm an engineer and I'm a hacker. And I grew up using computers in the early 80s. I had an Atari 400 and discovered bulletin board systems and just fell in love with this hacker kind of underground culture where it wasn't an industry. You didn't have cyber, even the word cyber, I don't even think existed at the time. But it was just curious people using technology. And I just loved that. I loved just communicating with people and sharing information, maybe things that you shouldn't have. But at the same time, loved building electronic products. And when everybody else in school was like, what do you want to be when you grow up? I want to be an astronaut or a firefighter or a policeman. I was like, I want to be an engineer, which is weird. Like, I think for a 7-year-old to say, in 1982 or something. But that was just what I gravitated towards, and I really liked it. And I always thought that my path would just be just a design engineer building cool stuff. And it just happened that my career has been kind of a hodgepodge of different projects. But engineering has always been there. Even when I got involved in starting a computer security consulting company, I was still the hardware guy. So engineering and kind of electronics has always been the background for everything I've done. And it's just been great to be able to do all these different things and kind of spread the message and spread the knowledge of what engineers can do, what hackers can do from a good side, and try to inspire people. Maybe that are there's some kid sitting in his parents' basement, just like I was, but now they're looking for something more to do.
What was your path from finding your passion into like getting into
professional?
Into professional life?
So I actually had a bunch of little hobbyist projects that I was doing on my own. But one of the first sort of, I guess you could say, businesses is there was an AT&T junkyard near my house in Boston where I grew up. And I would ride my bike there with some friends of mine that in future years we were in a hacker group together called the L0pht. And I discovered like this giant pile of EEPROMs. Erasable, programmable, read-only memory, UV erasable devices. And sort of turned that into a little side business of like selling EEPROMs, cleaning them up, erasing them, and then reselling them on Usenet, before eBay and all of that stuff. So it was really a lot of personal email writing and mailing stuff, and it was really kind of fun. So that was sort of an engineering business. But I built a lot of projects on my own, started with building projects out of magazines, and then said, I can kind of tweak this, make my own stuff. I did sell a few things as I was in high school, various mischievous devices and stuff. And eventually I got in trouble for more of the hacker-related stuff. And that's when I kind of straightened up and said, okay, I can do all this interesting engineering work, but I should probably focus on the good side. And that's when I finished high school, went to college, got my computer engineering degree, and then worked at a product development company called Design Continuum in Boston that the founder was a family friend of ours. And that was my way in. So it was really kind of a nice way. I still had to interview and everything, but at that point it was funny because I was doing some interning for them over the school year when I was in college. And these guys designed some major products, the Reebok pump, the original Reebok pump shoe, a lot of biomedical stuff, like products that actually help people. And I thought that was really cool. And I came in to help them. They had a board for part of it might have been the first digital pen sort of tablet thing for AT Cross. And they didn't have an electrical engineer on staff at the time. And they got these boards, I believe they were from AT Cross, to fit into their new industrial design that this company created for them. And the circuitry wasn't working. And they're like, Joe, you're the only person here that knows electronics. Like, can you take a look at this? And it turns out that the circuit board was supposed to have edge plating on it. But that was a fairly new technique at the time. And I feel like you don't really see it that much still. But the edge plating was missing. So in the pen, there was sort of a stylus at the bottom and a spring, and the spring was supposed to make contact with the edge plating so it would know when you're pressing the button down, and that wasn't there. So I said, we need edge plating. We got to paint on some conductive silver, whatever conductive trace ink that we got at the hobby store, and it saved the project. So, a year or two later when I go to apply for the job, they're like, he saved that project. He has to be hired. And that was my way in. So I was, just pretty much fresh out of school. With engineering training of building my own projects and all of that stuff. But it was really, for me, like 2 years of being able to learn the entire process from prototype, which is really where I was, all the way through pre-production to production manufacturing, with some high volume stuff, with some biomedical things and some other consumer electronics. It was really a great experience for me to be able to go to a factory. And I was, 20 something years old, wandering around a factory, leading up this project. So a huge experience, and something that I still say to this day, like I'd probably still be at that job if my hacker group that I was involved in hadn't decided to go off and start a company. It was just like that perfect engineering job of doing crazy, really fun, interesting things, and being shielded from all the politics, which is the other thing. Like that's something I haven't been involved in for a long time because I've been on my own. But every company always has these dynamics, and my manager there, who's actually still there, he kind of shielded me from everything. He's like, Joe, you just do engineering. I'll handle the customer, I'll handle everything else, just you go do the engineering work. And it was awesome. So I was like part lab technician, part project manager and all these things. And so great experience. And that was my first foray into real professional engineering.
That sounds like sounds like the perfect job for an engineer.
Yeah.
Just
like
do engineering.
It's like a dream job. It was amazing.
Don't bother with the politics.
Right.
Just do your thing.
And even it was like, don't even bother Joe. Like, talk to me. If you have a question, talk to me and I'll go relay it to Joe. It was amazing.
Beautiful.
Yeah.
Beautiful. It sounds like it was always very natural for you to just fix things up.
I guess the knack is sort of the problem solving, but I definitely have the engineering mindset, and the problem solving, it might just be because I'm always kind of thinking of things differently because of the hacker mindset, growing up in that hacker community of the bulletin board systems and kind of exploring the phone system and computer systems where I shouldn't. I've always kind of had this subversive kind of anti-authoritarian, authoritarian kind of view, and maybe that's what helps solve the problems. But it's definitely, as the more problems I encounter, the more confident I get in problem solving. But I wouldn't say it was like a natural thing. I think it just sort of like, there's just certain things about engineering that just kind of click that I can't explain. And it's just like, oh, you got to do this or do that. It just happens.
Was there a point in your childhood or along your way where it clicked and that you can remember that already gave you a hint that you're going to be going down that path?
It's funny because I think the first thing that I remember that really clicked was not even hardware. It was software. And I remember messing around with like a hex editor on my Atari 400 because I was trying to, I realized that I could load like a pirated game into the tool, and they have the crack screens that say cracked by whatever. I could load that software into this hex editor and I could see the characters, and if I changed the hex byte, it would change the character. So I sort of figured out the ASCII chart on my own. And I remember having like a highlighter and I'm writing these huge letters because I'm 8 or something like that, realizing that 4F is a whatever character. I don't know anymore because I look at the ASCII chart. But it's sort of like, so I just realized that that's how printable characters related to how the computer stored it. And that was the first moment I remember that I was doing something that really changed the behavior of something on the computer. Like I'd written games before then, and built some hardware, but that was the first thing that really stuck with me. And then from there, it's like as soon as I started building more projects out of magazines and then starting to create my own, like I think that was the next thing, is when I went from just copying the project in a magazine to building my own devices and etching my own circuit boards and like building things that I wanted to build, so more mischievous stuff. Like I built a high frequency tone generator that I could fit inside of like a little Altoids Mint box, and with 9-volt battery. It was like a 555 and a piezo and some other stuff. And I could set it to a really high frequency where I had a little tiny hole drilled in the bottom for the speaker, and then put it on my desk and in school. And so it looked like I just had a cold because I had my little tin there, and the sound was vibrating. It was bouncing off the walls and everything because it was high frequency. So you turn it on, it would just be this high frequency pitch, and everyone in the class would be like, like sometimes the teacher couldn't hear it because the older you get, that you lose that high frequency. But everyone's like, oh no, what's that sound? And I would just sit there, and that was sort of like, so I think when I realized I had the power to create stuff that was in my head was the other thing that was like, all right, this is the right path.
Yeah, it's beautiful how you found out that early, with still that curiosity of a child and kind of figuring out, hey, I can manipulate things.
Yeah, well, without the pressure of like, I have to do this for my job, right? It was
I think we, the older we get, the more we lose kind of that ability to explore freely, and to discover our world on our own, and then But as a kid, we have the opportunity to, do whatever we want, interact,
right.
and it's a beautiful.
Yeah. Well, that's exactly right, actually, and that's why even now it's hard, like running my own business, and I can pick and choose what I want to do. But if I'm not doing something that I feel is productive, I feel guilty, like that I should be doing something productive. But it's when you do the things that aren't focused just for money, right? It's like when you get to make the crazy things and mess around, that's when you really learn. And that's what I'm trying to get back to and trying to kind of inspire other people about, is like, it's hard a lot of times if you're working, 12 hours a day engineering to come home and then do your own stuff. But I feel like it's important to like do things that are fun and maybe don't even have a purpose, right? But in the long run, they will, because you might learn some cool technique, you might do something, or it's just kind of satisfying in a different way because you're not bound by all the, corporate stuff of what engineers have to deal with to get products out there.
Is the badgelife one example of that kind of started off as a...
Yeah, actually it sort of is, not for me, but for the rest of the community.
Can you talk a little bit about the badgelife?
Yeah. Phenomenon, I guess you could say.
If you want to say, yeah.
So badgelife is basically a group of hobbyists and engineers building crazy artistic electronic circuit boards. And it started kind of unknowingly with the DEF CON 14 badge. And DEF CON is a hacker conference, the world's largest hacker conference. And I'd been involved in the conference for a while. I'd known the founder and had actually created an artistic kind of shaped circuit board for a hardware hacking class that I teach. And it's in the shape of my logo. And my friend saw that, who runs DEF CON. He's like, we should try that for DEF CON. Like, do an electronic badge instead of like a paper lanyard or, a paper badge or whatever. So we made a run of, I think it was 6,000, kind of simple circuit, a little round circuit board with the shape of a DEF CON logo and two big jumbo blue LEDs and a little tiny PIC microcontroller, and it would just blink different patterns of lights. And we didn't know what people would expect. Oh, we had the PIC in-circuit serial programming debug interface on the back, so people could modify the code if they wanted to and kind of hack it. And just wanted to see like how would people respond to this. And people really liked it. They kind of messed with it. They soldered other stuff to it. And it was at the time where engineering and hacking hadn't really mixed yet. Like you had the engineering world and you had the hacker world, which was mostly software network type of stuff. But this was the first time we're trying to introduce electronics and hardware to the hacker world. And that's just took off. So we had the official badges for a few years, and then just groups of friends started making their own unofficial badges. And I think the first year, maybe there was like, a handful of unofficial ones. And then it kind of ramped up, and it's probably some exponential growth where at DEF CON 27, there must have been a few hundred custom badges, just ranging, from very simple, blinky light, cool art things to like really complex, amazing, beautiful badges with puzzles and all sorts of other things. And that's badgelife. It's like, it's something where, like any other engineering project, like it really takes a long time, right? And if you're doing something that you're passionate about and that you want to turn out well, it consumes your life. And that's kind of, that's what badgelife is. And to see so many people in the hacker world, but also just the engineering world, start building these things is awesome, because it's, part artistic sort of freedom. People are creating lots of basically reference designs and evaluation boards that other people can use and build on and do stuff with outside of the conference. And then trying new techniques and all sorts of things that people might not be able to do in their real job. And then just also trying engineering, like if they've never been an engineer. So it's just a crazy community. And to see it kind of from the outside, because I've designed the official badges, but I haven't really designed a lot of unofficial badges, just because I've been focused on other things. And to see people, and I don't feel like my mind is as creative as most of the badgelife people that are doing, these things. So it's fun to see it and just kind of see how it's grown and see how different techniques that they're sharing, and just the beauty of some of these badges now are crazy.
Yeah, I've seen some, you can even play games or collect things. They've made it actually pretty interactive as well, right? At DEF CON. Wasn't there a tree or something?
Yeah, so some of the unofficial badges will have usually a game associated with it or some puzzle or something in the badge itself. For the official badge, the tree was the DEF CON China badge, which was one I designed. So the official badge for the first official DEF CON China, which was in the spring of 2019. And this was something where I had retired from designing badges. I stopped after DEF CON 18. So I did 5 years of official badges using Altium Designer, which is funny because the only tool I've ever used starting with easy tracks was sort of Altium and Precursor, where most of the community are using other tools, and I just have always used like these professional design tools. So I took 9 years off after DEF CON 18, where I did like an aluminum substrate board with laser engraving, and sort of thought I reached my limit of kind of engineering creativity at the time, and figured because badge life was so huge, it's like, well, I don't want to keep competing with myself. Like, let's see what else happens with the community. So 9 years go by, and the Dark Tangent calls me up out of the blue and was like, hey, do you want to do the badges again? And I feel like I sort of forgot the life part of badge life, like how hard it actually was to do and how much time it took. But I was looking for a project, you know, and it seemed like the right thing to do. And I said, okay, if I'm going to do it, I want to try some technique that I've never used before. So the badge ended up being a flexible circuit, which I'd never done flex before. And it was in the shape of a tree and had a little flex FPC connector on it. And the concept is you had 16 LEDs on the branches of the tree, 16 LEDs on the roots of the tree. And as you completed different tasks at DEF CON, you'd plug in the FPC connector to a little programming board at the different stations at the conference. And as you did that, you would enable each different root LED. And once you completed 4 roots, the 4 LEDs of one root, part of the tree would light up. Once you completed everything, then all the tree would, you know, blink and sparkle. And it was just like a fun little simple in theory project, but people really loved it because it had this kind of interactive component. They got to go experience different things that they wouldn't normally experience. And for me, I got to spend, you know, hours on the phone with the circuit board fabricator, like figuring out the stack up and making sure, you know, the adhesive thickness was the right thing and that the stiffener thickness was the right thing to match the specs of the connector, and was everything going to work. And we built, you know, one prototype, and we didn't have time to do anything else. So one prototype and then to production. And it was a great experience to learn all about flex, and we had white solder mask or white cover lay on there. And so basically it was like wearing a thin piece of paper with a little microcontroller circuit on there and a CR2032, and like that was pretty cool. So, and that's the thing, is like being able to try technologies. And I found out about like the teardrop feature, you know, in Altium is like, for flex boards, that's perfect because you're adding, you know, extra material so you don't deal with the mechanical problems and breakage at bend points. And like, that's something I'd never considered before, you know, and it's just like learning techniques like that, I feel like just make you a better engineer.
Yeah, are there any other projects from your past where you have those examples of you learned about teardrops? So yeah, that absolutely makes sense. Are there any other examples that you can think of from projects?
Oh, for sure. Yeah, I mean the other one that comes to mind is DEF CON 27, which was also 2019. I was basically working on DEF CON China and DEF CON 27 kind of in parallel. There's some overlap. And DEF CON 27, the attendance, we had created 28,600 badges, and we ran out. So we had at least 29,000 people there, and that's a lot of hardware to build, especially for one person, you know. And like, I mean, I had a contract manufacturer and everything, but you know, just having to deal with supply chain, part sourcing, purchase orders, hardware engineering, firmware, everything was a lot of work. That was like 9 months of full-time work just for DEF CON 27. But just like China, where I was like, I want to try something new, for the US show, we didn't want to overlap any technology, so I had to start from scratch. And I said, I want to have some interesting communication method so attendees can communicate with each other, but I really wanted to work with BGA, micro BGA, you know, buggered array, micro vias, via in pad, like all these high technology things that I just never worked with before. Because I normally do a 2-layer, 4-layer board. Up to 10 layers is what I've done, but nothing really complex. And I just wanted to kind of go extreme. And a lot of badges, you know, are using hand solderable surface mount parts or through hole parts. And I was like, how small can I get? So that was my goal of like, let's make this as small as possible. So I had to learn about, you know, creating BGA footprints and the solder mask over the pad, or if you're going to have the solder mask around the pad, all these technical things about BGA parts. And the time frame was sort of the same thing, as we had time to make 6 prototypes. and assemble those, x-ray them to make sure that all the footprints were right. And I had 7 days to verify all the hardware, so write enough code to make sure all the hardware worked. And then we had to pull the trigger on 28,600 boards, even with the changes I made from the prototype to the production. So not really recommended, but sometimes you have to do that with engineering. It's like you have a deadline and you have to meet it. I would have liked to get in an additional run just to kind of iron out some of the potential problems that the circuit board fab could have had, or that assembly would have had more time to fine tune their process. But given that we didn't have time and we had 1% failure, which is not bad, but learning all about the BJ components and super tiny parts and routing all of that stuff and doing fan outs and things that the via in pad and the blind vias and like all these things, or the buried vias in between the inner layers. It was a 4-layer board, just crazy complex. And like, to me, it was a great engineering experience. Painful because it was really stressful and I probably got a bunch of gray hair from it. But to learn those things and be confident with like, I can use these modern parts and I can use modern circuit board techniques, and not be afraid of that. Like that was, to me, really empowering. And the troubleshooting aspect of it too, of like, okay, now there's a problem. I'm the only one that can fix it because this is a project, or I can't talk to anybody about it except like a few distributors and things who know what I'm doing. Like, it's a secret. So I really had to focus on that engineering process of like finding the root cause of the problem, right? Not settling on thinking you found the problem based on fixing the result, but finding the root cause. And that took a lot of work and many hours and a lot of stress. But it's like, once you start solving problems like that, you realize, okay, you just follow the process, you work on it. It might take a day, it might take a week. And you might solve it when you're in the shower. Like, you don't know, and you have to run out and like, towel off and then go fix it. But that's really like the beauty of engineering. It's like you hate it and then you love it at the same time. And that, so to me, that was a very memorable project. Not that I would want to do that time frame again, but to make me a better engineer, yeah, definitely.
Yeah. So if you consider the PCB design process from idea to final board, what would you think are the top 3 things that you need to keep in mind, or things that you would have done differently maybe the first time you went through it?
Yeah. So some of the things, it's funny because the design tips that I always have in my head, to me, seem really simple and obvious. But being on my own, I create my own footprints, and my parts library, my component library is all mine. So when I'm doing that, I think something, I feel like unless you're in an organization that has a vault and people are storing things there, if, for individual designers, verifying your footprints, right? It's like you're designing them based on the data sheet and the mechanical information in the data sheet, and you think it's going to be right, but I always do a 1-to-1 print and verify everything. The smaller components are going to be harder to do, but at least to give you an idea of like, am I way off? And that, even to this day, I still get in trouble because I've printed stuff out and it looked okay, but then it turns out that I couldn't align the component just right and the drill hole ended up being too big, right? So like the pads are okay, but the drill hole was, so it's these things. But I think doing a 1-to-1 printout, verifying your footprints is huge. Having time, if you can, to kind of iterate through your process. I like to start with building like a breadboard prototype. So having a plug board and building up my circuitry. Again, for more complex stuff, high-speed stuff, that's going to be harder. But just building it where I can more easily change components out, make sure everything works. Then I'll create the schematic from that, do a preliminary board layout. So sometimes if the board is very complex, I like to have a big board with lots of test points, easily repairable circuit board. So have all the traces on top and bottom layers if I can. So if I have to cut a trace or do something, I can do that. And then go to the final product. And usually in between, there's going to be some pre-production version as well. So having multiple steps, but sometimes you can't, right? And it's like you just cross your fingers and hope that things are going to work. But if you have the time to go through the right process, that's going to save you a lot of trouble.
Altium Designer. Do you think Altium Designer can support you as a tool in kind of that approach of streamlining your engineering to a point where you don't have to worry so much about all these non-engineering tasks?
Yeah. Oh, for sure. I mean, I remember back Using easy tracks or early other tools, non-Altium tools, it makes it nice. And to be able to switch back and forth is good. Make changes in the board, bring that back. Things that could just make my life a whole lot easier. And the one that really, I remember putting a star next to it this morning of like, you can move a component and it will at least attempt to recreate or reattach all of the traces that you'd already done. So not just leaving you with the broken nets. And that's huge because I like to really move things, even like 1/1000th of an inch at a time to kind of move things in place. And then I would have to redraw all of those traces. So, the tool has been really powerful, really useful. I feel like I'm just scratching the surface of it, and I've been using it for, again, most of my professional career. So I'm sure there's way more capability than I could ever need, but I know for a fact that it saved me, and it's a solid tool that I'm comfortable with, all of my history with it, and to be able to grab my snippets and grab my bits and pieces of footprint and other designs and kind of reuse those. And I know how the tool is going to respond. It's a great tool. And I always tell other engineers, it's like, look, you can go with some of the open source tools or other options, and there are lots of them, right? And people do well with those. But if you're serious about engineering, like at least try Altium Designer. I'm not out there like shilling and selling the product, but I use stuff that I use because I like it, right? And that's the thing is like, it's a useful tool. And I'm always of the school of like, getting the right tools that are going to do the job, whether it's Altium, whether it's a device programmer to read memory, whatever it is, like just get the tools instead of trying to hack stuff together. For this situation where there's already something that is going to solve your problem, like creating something from scratch or struggling with something is probably not worth the effort. And then you can focus on the fun stuff of actually creating something.
Yeah. Did you try any other software before Altium?
At Design Continuum, we used OrCAD for capture, and then we weren't doing circuit board layout. There was a professional company doing it. I think because the tools at the time, like you actually had to be a professional circuit board layout engineer, right? You couldn't even have a design engineer work with the tool. So I think they were using, Cadence or some pads. I don't know. So it was expensive and hard to use. And then I just started using Easy Tracks in DOS, kind of progressed from there. So using Protel, whatever it was called, summer, whatever the different seasons were. The way that I was learning is just clicking around and kind of messing around. And my design started off simple. The first professional board design I did with Easy Tracks is a little tiny, basically a little op-amp circuit that takes in analog data from a radio and then will just level shift it to just throw it to the rails to make kind of digital data out of it and feed that into a parallel port to decode some data for pager traffic, like old pagers. And that was a fairly simple board. So it's kind of, I've learned the tool as I've gotten better at engineering, so it's just like, now that I am familiar enough with the tool, I feel like it would be really hard to change to something. But the only time I've used another tool is if I need to load a native design file in to like see a schematic or see a board layout or something. And then I go straight back to Altium.
That what Altium intends to do, make an engineer's life easier, that it actually does.
Yeah, well, what I like about Altium too is the forums are there, so you have a good community support, which I lurk on those. I don't even know if I've ever posted, but I have submitted some trouble tickets for bugs and things, and the response is really fast, and that's what you would expect from a professional tool, right? It's like, if it's a tool that maybe isn't with an established company, or it's a group of people doing it in their free time or whatever, as a professional engineer, when you need an answer right away, you need a problem solved, like it's hard to rely on that. So even just going through the forums and the documentation and seeing some of the videos that people associated with Altium are making, it's amazing. And it's like, I need to learn how to make, do castellated holes and all these things of like, you can just go find out how to do it. And like, it's really kind of neat. So I just like that. I just like having tools that I know are going to work, because then I can focus on stuff that I want to do and not waste half the day, solving a problem.
If you had an aspiring engineer sitting next to you, maybe, starting university or...
Yeah, I think really the first thing is just build things that you like to build, right? And it's like, if you can start with creating something, maybe it's as simple as using an Arduino and adding a sensor to it or something, but like building something that is useful for you. Because then from there you learn something, but then you also have something that like you're proud of and you can show other people. And engineering nowadays is everyone standing on the shoulders of giants. Like there's a lot of work out there, a lot of libraries, a lot of design tips, a lot of ideas, especially with the hobbyist community, with Arduino platform and open source hardware and open source software. So it makes it easier for people to get involved and like build their own stuff. And then releasing that back into the community also. Like that's the other thing, is if you take something, you build on it, you make it better, you throw it back out there, and then that knowledge is out there for everyone else. So I think that's the first thing that comes to mind, is just building something that you love and learning as you go, and then sharing it with everybody. Don't be afraid to ask questions, but also don't be afraid to search for the answers yourself. And that's a little more of the hacker mindset, where I'll get emails sometimes of somebody asking some technical question and the answer is in the manual that I wrote, or it's on page 32 of the data sheet. And so I think, I don't know if it's the age of instant gratification and text messages and everything being available at your fingertips, that if somebody doesn't immediately find it, they ask for help. And I think that it's really important for people to go and dig deeper and learn and read the data sheets and read the documentation and look through the source code, look at previous designs, hardware designs, and question things, but try to figure out the answers on their own maybe before just asking for a solution. And I think that's an important one. It's really just trying to stretch your mind a little bit. And if you get the answer wrong, that's okay, right? But you might be able to find out the solution on your own. And then ask a question at the end if you really can't do it, right? But yeah, don't be afraid to try on your own.
Do you believe anything is possible?
I think anything's possible. Yeah, except maybe time travel or something like that. But and that's the beauty of engineering, is if you have an idea in your head and you spend the time on learning the techniques and learning the background of what you need to do, you can probably achieve it. You might need a team of people to do it. You might not be able to do it all on your own anymore. But I feel like the tools are there, the resources are there. And that's really the cool thing, is you have this idea in your head that doesn't exist, and then you bring it to the world. And that's I think there was a quote from an artist. I'm totally gonna botch this, but it was something about create things that you want to be seen in the world. And I think that's a perfect kind of summary of engineering, is you have an opportunity to create things, and creating things that deserve to be in the world is pretty satisfying. So that's kind of the fun about it, is you go from your head to a real tangible thing that excite people and inspire people and maybe change the world, maybe help somebody with a problem or something. That's kind of cool, if you really think about it.
Besides engineering, what do you do when you do not engineer?
Yeah, so something I learned early on when I got in trouble as a kid, when I was just hacking on things all the time, and I call myself a technological juvenile delinquent. So I was basically, I was just a troublemaker, behind a computer and on the streets, skateboarding in Boston and causing all sorts of trouble, because I always had that hacker mindset, that subversive mindset. So I learned when I got in trouble to kind of have a balance. And I started running track and field in high school after I got in trouble, not because I was a good runner or that I had any athletic capability whatsoever, but I had a few friends that were non-technical that were running track. And they're like, run track, it's fun. We hang out after school and go for a run. And I'm like, cool. So the first day I went out and ran 8 miles, got a stress fracture, sat out most of the season, but sort of realized oh, it's kind of fun. It's a good balance. So when I'm not engineering, I'm running and trying to get more into yoga and meditation, and just because I'm pretty high strung as it is. Just that's my personality of always just go. And to be able to settle down and be bored, allow myself to be bored and allow myself to just work on things that aren't completely necessary, that's important. So still trying to do that, but running is the main balance that had definitely kept me out of trouble, and has shaped my life almost as much as engineering has, which is really nice to kind of have that.
I know while running, your brain is working a lot as well, right?
Yes.
It's kind of like sleeping, where you kind of
yeah.
digest and you have time to
Yeah, it's kind of meditative, but you're almost processing subconsciously a lot of times, and you get in that, like with running, you get in the zone of like this effortless exercise. Sometimes it hurts a lot. It's sort of like engineering. Like sometimes it's great, and sometimes it really hurts. But I have solved problems on runs where a lot of times I have to force myself to leave the office, and that's something where with the DEF CON project I didn't. And my wife was, would always say like, you need to go out for a run. I'm like, I can't, I have to get this done. But she was right, because going for runs is when you step away from the problem, but you're kind of still thinking about it, and you can come up with a solution a lot of times. So I think of a lot of engineering solutions when I'm running. I think of a lot of the writing that I have to do, whether it's an abstract for a conference or something for my website or whatever. Like I think of those things, even though I prefer to not think of anything when I'm running, but it just happens because my brain is going, and it is a great way to solve problems. And the shower is the same thing. I think it's that white noise or something where you're standing there and then you come up with a solution, and the trick is to still remember it when you turn the water off. Like I found that's a big problem. So I usually have a pad of paper in the bathroom or right in my bedroom that I can go run to and like write stuff down. Just because you never know when inspiration will strike, and it's, if you're so focused on it and angry that the problem's not being solved or whatever, like I feel like then you're preventing yourself from being able to think of the solution, which for me is really hard because I'm going to just obsess over that problem until I can solve it. But when I force myself, or somebody else forces me away from the computer, out of the house, even just to go walk to get lunch, like it's something as simple as that, you can kind of reset, go back, and then kill it.
Yeah. You're supporting the right to repair movement.
Yeah.
Is it a movement?
I would say it's a movement. It's a grassroots effort. Yeah.
And it's something that's also dear to my heart. I found this guy Louis Rossmann.
Okay.
You know that guy?
Yeah.
He's like taking apart Apple stuff.
Yeah. Okay. Right.
But can you talk a little bit about that right to repair grassroots movement?
So right to repair is this grassroots effort to raise awareness of the fact that large corporations, mostly large corporations, are making it hard for end users to repair their own electronics and hardware products that they buy. It's sort of like a lot of technology now that you buy it, you're not even owning it, you're leasing it, you're renting it. And some of the end user license agreements that come with the hardware actually even say that. They say you don't own your hardware. But I'm of the school of like, you pay money for a physical thing, you should be able to do whatever you want with that physical thing. Whether it's changing the battery, something simple like that, fixing a cracked screen of a mobile phone, or maybe you want to modify it to do something completely different, right? Hack it to do something else. It's mine, I should be able to do what I want with it. And Right to Repair is really trying to raise that awareness, and really as a lobbying organization to go up against these giant PACs and corporation-funded organizations that sound like they're these official things that are really just a front man just spewing all of this garbage about how important it is to prevent end users from modifying their devices. Trying to explain to the lawmakers and to politicians and to people to try to build it up of we should be able to use what we own, and why should we give our rights away to these companies who are exploiting us anyway with not only using the hardware but tracking us and data monitoring and data harvesting and all these other things. We should be able to repair our hardware. And the legislation that we're trying to pass and get passed is that these corporations should at least give diagnostic information, repair manuals, schematics would be great, but there's going to be different levels depending on the product, authorized support, availability of authorized components, and not limiting it to certain corporations, just making it sort of like it was 20, 30 years ago, where the first Apple computer or even the Apple II, you'd buy it, you could get a book of all the schematics. You could even get a blank prototype board that would fit in their expansion slot, and that was all made by Apple. Like they were encouraging people to hack on their stuff. And now you look at it where to change a battery in a laptop is like a multi-hour process. You need certain tools. Technical people can do it, but most users are not technical users, and it's too hard to change a battery. It's crazy, and it's $1,000 devices or more, and it's like it's really putting the end users at a disadvantage. And the companies are actually basically going out and saying that end users, their customers, are too stupid to fix devices, so we don't want them to break anything, which is ridiculous, And it's like the automotive industry went through this. Now you can go to a garage anywhere and get your car fixed. It's not limited to certain people. Home appliances, the same sort of thing. Washer, dryer, that type of stuff. You can get the manual, you can get the parts. You can call any number of people to fix your stuff. It's not this monopoly of certain things. But consumer electronics and technology in general hasn't really seen that. And it's just a scary prospect, because the more disconnected we are from the technology and being able to repair it and modify it, the more in control these corporations are, and the more that we're beholden to them to really do anything in life, because everything is kind of controlled by this technology now, by mobile phones and internet connected devices and everything. So it really just comes down to being able to do what you want with the hardware that you buy.
Yeah, well, that's a very good point. Especially, I think one projection is that by 2020 or 2025, they want 50 billion IoT devices. I'm not sure if I got the
it's some huge amount, yeah.
Yeah, it's just huge. And I mean, even that couch that you sit on is going to be smart.
Sure,
probably
yeah.
Talk to it, have conversations.
I just saw a self-driving garbage can.
Yeah.
To bring the garbage can out to the street for you. And it's like, just drag the garbage can to the street.
It could be a good way to get away from the computer to let you.
Well, right. I mean, it's going to be good for senior citizens and, other, people with disabilities. But in general, it's not needed. And I feel like I'm definitely a technology curmudgeon also. Like, being in this world where you see all the technology being created, just because it can be created doesn't mean it's actually useful. And that's a problem, because we're losing a lot of personal contact and other things because of the technology. But yeah, I mean, with internet connected things, there's security problems with that and stuff that we I could talk for days about. But we're just seeing more and more devices out there that are smart devices, and the technology in itself is kind of cool, like smart, self-driving, whatever. But it's really the data harvesting and the usage information and the mapping that gets sold. Like, it's not really the technology itself that's the problem. It's how everything else around it, the whole ecosystem, is being used and treating you as you're not really the customer, you're the data, right? Like, you're the product.
So I think many consumers out there, more than many, are not aware of that.
Yeah.
So they like the benefit of
well, sure, it's cool, right? It's like,
yeah, but you as a hardware hacker, you must be well aware of some security breaches.
Sure.
Especially with the IoT.
Yeah.
You have so many more open doors.
Right. Well,
can you kind of sum it up?
Yeah, I mean, internet connected devices, IoT devices, are basically just resource constrained computers, right? So you think about your laptop that's on the network. Now you have your internet connected camera and your internet connected baby monitor and your internet connected door camera and your door lock and all these things that are all connected to the internet in some way. And engineers are not trained to design secure products. You might have a few that are, but usually not, right? Like we talked about, engineers are bound by certain constraints of getting the product to market, getting it working, getting it under budget. Security is not there. Even if it is there, it doesn't mean they're doing it right. So there's huge security problems. And it's funny because from my perspective, when there's a hack of like somebody hacked a baby monitor and they're spying on a baby, to me that's not surprising, right? Because it's like, of course, you have this badly protected piece of hardware on your network. Someone's gonna find some default password or some backdoor that an engineer put in or without hard-coded password, whatever it is. But most consumers don't know that. And the problem is that the product companies aren't sharing that information either, right? They're not saying, if you put this on your network, you could have some creep spying on your baby. Like, they're not saying that stuff. And that's the problem. They're sort of selling all this stuff to you and people think it's great. But I don't have anything in my house that is remotely network connected because I know the problems with it and I know what could happen with it.
What would you tell an engineer who designs an IoT device? I mean, of course, you need to go through, go study some security. Specific get some additional knowledge. But
right.
Is there anything that you would tell somebody who next to you somebody sits who is working on an IoT device? What would you tell them?
You can never be 100% secure. But the problem is we have so many common types of security problems out there, and a lot of them are actually circuit board related. So it's leaving test points on there. It's leaving debug interfaces, easy access to memory, easy access to communication buses, all these physical board access things that I call low-hanging fruit. The problem is a lot of those are needed for manufacturing. So you need your test points for your certain signals to be tested. You need your debug interfaces for programming. So it's trying to think of how you can lock those down in some way. Maybe you can implement some password protection or some other things. Sometimes the chips themselves will let you lock down the interfaces once you've used them. And those are good first steps. It doesn't mean that that's going to make your product secure, because there are known methods to defeat those types of security protections. But at least by enabling code protection and locking down your device and just doing some of the simple things will, for lack of a better term, like raise the bar and increase complexity of hacking something. But when you come from the network side, most products are going to rely on some existing network stack or some module that connects to the network. A lot of those have already known vulnerabilities in them. So you're kind of building in vulnerabilities into your product without even knowing. But it's really just studying like how can I get my product to function as simply as possible by reducing my risk or reducing my attack vectors, my attack surface. So closing closing unnecessary ports. Again, not having backdoors and hard-coded passwords, and understanding proper encryption and key storage and things. So I think a lot of just kind of basic general security concepts need to be studied and understood. And there is a lot of information on my website of kind of recommended best practices that aren't necessarily solutions, because you still have to implement them properly. But it's just a place to start, right? Of like, okay, let's think about how a hacker is going to attack our particular product, and then choose the things that we can do in a cost-effective way that's still going to make our product work, but let us lock it down. It's a super hard solution, or a really hard problem, and something I don't envy anybody's position who's designing IoT devices. I just feel like, as a whole, we could just take some better steps to just make things slightly better, slightly more locked down. So it's just not as easy as somebody to connect to 100,000 internet cameras and use them in some way, or to spy on your baby or something like stuff like that. It shouldn't be that easy.
Yeah. So your website is?
My website is grandideastudio.com. You can also find me on Twitter @JoeGrand. I don't use it very often, but once in a while I'll come up with some gem of insight or knowledge or something. But my website has a portfolio section with kind of split up into consumer electronic stuff and hobbyist and security. And pretty much every presentation I'll put up there, any project, I'll share as much information as I can about it, depending on what it is. And yeah, just try to inspire people and get people excited about engineering, and try to roll that ball forward as far as the knowledge in this world.
So I want to close with the question about the future of electronics.
Ooh, okay.
So obviously it's going fast, very quickly.
Yeah.
So what's your view on the tomorrow of electronics?
Ooh, I hope, and I don't know if this is true, but I hope that we're going to reach a point where the users, the customers, the consumers kind of wake up and revolt, right? And say to these big corporations, and say, we don't necessarily need all this stuff. Like, we don't, maybe we don't need social media because we can talk in person like we used to, or something. Like, I don't know if that's going to happen, but I feel like I just hope that people will rely less on technology, use it for what's needed, but not use it for everything. And that's hard to say, because I don't use a lot of technology, and I'm definitely out of the loop for a lot of stuff, because I don't get on chat rooms anymore. I don't do any of the chat stuff that happens. No Facebook, no other things. Twitter is that only kind of way of shouting information, but I don't communicate on it. So I'm missing out on how the world is going because of that. But that's a conscious choice, because I'm sort of choosing not to be a part of that. And I'm hoping that more people do that and realize to kind of come out and be like, oh, wow, like I don't necessarily need email on my phone, because if I'm out somewhere, like, am I actually going to answer the email? Probably not, right? Like, you go home and do it at the office or whatever. Like, the number of people that actually have urgent things that are needed to be done at that time with a piece of technology are few. Most people are just hooked on it. And I started deleting, I deleted mail from my phone. I deleted all sorts of other apps, turned off direct messaging, like all these things to simplify kind of my usage of technology, and it's just made me happier, like less stressed when I'm sitting outside waiting for the bus. I'm not staring at my phone, I'm just looking around, and it's like there's something lost that we've lost with that, and I don't know if that's just me, like this is going to be great if everybody stops using technology, but that's silly to say because we know it's going to progress. I just hope it progresses in a way that we realize the useful technology versus the technology that just sucks us in and really doesn't do us any good.
As I said, this show is for engineers out there, for anybody in the PCB who is excited about PCB. And so what would you tell aspiring engineers or engineers out there to become better engineers? What can they do to become a better engineer? To
become a better engineer, I feel like you have to fail. And by failing, if you pay attention to how you failed or how the product failed, you can learn from that and use that and remember that for the future. The problem is it's really hard to fail when you have pressure on you to get it right. But I feel like it should be okay to fail, and maybe it's not going to be okay to fail, but you're going to learn from that. You don't always have to play it safe, but learning from your failures is okay. And like don't be angry that you failed. Be happy that you can learn from that failure and do something with it.
All right.
And hopefully you don't get fired if you fail.
All right. Hey, thank you so much.
All right. Yeah, thank you.
Anything else that I missed?
No, this is great. I appreciate it. And yeah, if people want to learn more, like Prototype this or the L0pht, which is the hacker group, like all that's on the Altium podcast, and just other ways of spreading the hacker message and spreading the engineering message. And I think and that's it. It's just like, I hope people share their story too and share their designs and their things so we can all kind of learn from it, right? And it's like, this is it's a career, but it's also a community. And that's the thing, is you can always learn more no matter what. And that's the key. So hope that's it. I appreciate the opportunity.